Welcome to this quick tutorial on how to use the freeze-thaw datasheet. Now, whenever we are developing skincare or hair care products, personal care products, any kind of products at all, it is very important that we ensure that the quality and safety of the products are not only on point when we develop the products, but they also need to remain standard or stable over an extended period of time. Stability studies is a special kind of test that essentially gives you an opportunity to see if your product can withstand extensive variations in time or in environmental quality such as temperature, to see if your product is actually stable and if it will maintain its effectiveness over a long period of time. Because of course, depending on your products, your customers may have your products for several months, maybe sometimes several years. If your products are being sold in stores, sometimes they will be on the shelf in stores for an extended period of time, several months, several years. And you want to ensure that the product itself will remain stable and that people can continue to have confidence in your products. One kind of stability test that you can use is a freeze-thaw stability study. This type of study allows you, gives you a very rapid way of testing your product, and you can make some assumptions that if your product maintains its physical and physical chemical properties over the freeze thaw exercise, that it will likely maintain its parameters, these quality parameters, over an extended period of time. So it is a very quick way to assess the stability of your products. It is not necessarily a replacement for real-time studies or accelerated studies, but at least it will give you some preliminary data as to how stable the products are, and it can help you to move forward to the next phase of product development, or at least to do some market testing. Okay, so with all our spreadsheets, we have a Start Here tab. So here you can go in and read the instructions. So again, make your own copy, save it to your folder. So you're gonna need a Google account in order to use this particular tool, because it is in Google Sheets. Once you have made a copy, the first thing that you will do is actually go to the data sheet where you will update information on your particular product. So let's say you are looking at vanilla bean body butter. Okay, you can give it a name. And then I always strongly recommend that you have the formulation code in your data sheet as well. We all know as formulators, we will do several iterations of a given product. And if we lose track of what iterations or prototypes link to what data set from our stability studies, we can end up wasting really valuable and amazing products, right? Because we forget which formulation is for a particular product that we're looking at. So ensuring when you're doing your product development, each prototype has its own unique code. And then once you're advancing that particular prototype to stability studies, then you ensure that that sample has that particular code as well. Based on your ingredients, you should be able to give a predicted expiry date. So it may be 6 months, it may be 12 months, 24 months, 36 months, depending on your particular formulation. Putting that information in will at least give you some idea when you do your stability studies whether it is a feasible expiry date. When did you start the stability studies? When did it end? And if there are any notes or assumptions. So let us say you're doing the stability studies because you have a product that's currently on the market and there are some quality issues that emerge at some point, and you now want to go back through the product development process. Maybe you're changing a particular ingredient, so let's say this body butter all of a sudden starts to melt when it gets hot, and you may decide you're gonna now add some emulsifying agent to it. You may decide to put that through freeze-thaw studies to see if it holds. So making those notes or assumptions can also help as you reference the information to connect all the pieces during your product development process. And always, especially if you have a team, ensure that you put the name or names of persons who are conducting the study. Okay. Now, the process for freeze-thaw studies really can vary. There is no one way. There are some general guidelines, but every lab, every business has to come up with its own specific standard operating procedure for its product testing, including stability studies testing. However, I have included some general guidelines. These are the guidelines that we use in our lab, so that you can create your own set of guidelines, and it will help you if you're new to this to at least test your own internal methodology so that you can come up with a final method. So the very first step is to determine what study parameters you're going to be monitoring to assess stability. So are you going to be looking at color? Are you going to be looking at pH? Are you going to be looking at viscosity? Texture? Are you going to be looking at the size of the exfoliants under a microscope? Are you going to be looking at specific density? Are you going to be looking at some kind of efficacy metrics, or something such as its ability to heal a wound, or its ability to remove a scar? If you're looking more at your cosmeceuticals, what are those qualitative and quantitative parameters that you're going to be monitoring? For the average small independent brand, oftentimes you're looking at your basic quality parameters that are important for your customer. So things such as color, fragrance, emulsion, stability, those kinds of parameters are typically important for your customers, and you should have those included. You may have more scientific metrics such as pH, microbiological parameters such as aerobic bacterial plate count, yeast and mold counts, the presence or absence of certain microorganisms such as Staphylococcus aureus. If you're looking at those specific things, you can put those down as quantitative parameters. But by and large, I think most small startups will be looking at things like pH if it's a water-based product, viscosity if you have your own viscometer. You can also do skin patch testing. So if you want to monitor whether the likelihood of irritation is maintained through the freeze-thaw study, you can include that as well. So it's very important to determine what those study parameters are. Every product is different. Every business may have different parameters. Every market may have different parameters. Every jurisdiction may have different parameters. So in your country, for example, they may insist that certain parameters must be monitored in your stability studies, such as microbiological data, for example. You may have to produce that as a requisite as a requirement by law, depending on where you live. So you're going to have to determine what those are, and then you're going to include that in your data sheet. So for example, we may say color as a qualitative measure. You may say fragrance or odor. Maybe another metric that you may use, something like texture. You may include state. State may be more of a maybe a more quantitative metric. And then quantitative metric could include things such as pH, for example. So there's specific readings, it's an objective measure. You could put that in your quantitative parameters. So the freeze-thaw study is, as the name suggests, it goes through freezing and then thawing out the product and looking at whether these extremes in temperatures affects the qualities of the product. So usually you have a specific amount of control, a particular amount of sample that is weighed for both your control and your test. So your control is that product that does not go through the freeze study. So it may be just at room temperature. So you may decide to weigh 10 grams, and that's why I've left the question marks, because it depends on your lab. You may do 10 grams, you may do 100 grams. So you can put that detail in. weigh X number of grams, and you're going to have a control and you're going to have a test sample. Your test sample is what goes through the freeze thaw process. Your control sample does not, and the control sample will demonstrate the specific requirements or criteria for your parameters, and that is what you will use to compare to your test sample. So once you have your control sample and your test sample, it's best to put that in a clear container, so at least you can easily see the product. Glass is always better because at least you negate the potential interaction of plastic and paper with the product itself. Or you can put it in your intended final packaging. So if you are very, very sure that you're going to be putting it in a 2-ounce PET cylindrical Cosmo bottle, then go ahead and put it in that so that you can do your studies. Then you're going to place your test sample in a refrigerator or freezer at 10 degrees Celsius for a period of 24 hours. You can put it at 4 degrees Celsius. You can decide how you wish to at what temperature, but I always recommend that you use a very specific temperature and you maintain that for every single study that you do. And then you're going to leave it there for 24 hours. Depending on the product, it may freeze. Some of your products will not freeze because it takes much lower temperatures in order to freeze the product. So water will freeze. For example, at 4 degrees Celsius, you may have some amount of freezing. Some of your oils will solidify at even much lower temperatures. So you may have some... water freezes at 0 degrees Celsius, but when you have an emulsion with other things in it, it may freeze at 10 degrees Celsius. It may freeze or solidify at 4 degrees Celsius. Once you've had it there for 24 hours, then you're going to place the test sample on a counter on your lab bench for 24 hours. Allow that to thaw. And then after 24 hours, you're going to place it in an incubator at 45 degrees Celsius. It may also be at 37, between 35 and 45 is a good number. So you want slightly warmer temperatures. So this, for example, would be, in particularly warehousing. Whenever your products go into a warehouse, often it can be very hot, or if you're going to vendor events, you may be carrying your products outside during the summer when it gets really, really hot. You want to see whether your product will maintain its quality between warm temperatures and room temperature, because that's a normal transition if you're storing them at home where it may be cool, and if you're carrying them out to a vendor event. Then after it being in the incubator for 45 degrees Celsius for 24 hours, then you're going to bring it back to room temperature for 24 hours so that it can normalize, and that completes one cycle. So at a cold temperature for 24 hours, then room temperature, then a warm environment for 24 hours, then room temperature. That's one cycle. After one cycle, or after each cycle, you're going to evaluate or test the test sample and the control sample for those quality parameters that you have decided on. So let us say hypothetically, okay, so I have put my vanilla bean body butter in the freezer at 10 degrees Celsius. Then I put it at room temperature for 24 hours. Then I put it in an incubator for at 45 degrees for 24 hours. Then I remove it out, and for 24 hours I leave it at room temperature. That completes one cycle. Then I'm going to look at the control, and I'm going to look at the test sample. And the control might be a light brown. The fragrance may be vanilla fragrance, and the texture may be buttery or butter-like or creamy, whatever, right? It's really for you to come up with a criteria or a metric that you can use to compare to everything else. The state may be solid, but it's a cream, and the pH, let's say maybe 5.8. Okay, so that is your control metric. So your products being stored at room temperature will always have that criteria. Then for your test samples, what have you observed compared to the control? Okay, so after putting it through the freeze, thaw, heat, thaw cycle, what are you seeing when it comes to the color? So there's no change, so it is stable, yes, no notes. The fragrance, no change, yes, it's stable. Has the texture changed, right, from buttery to creamy? There might be a change, and the change might be it's no longer buttery, but it may be it may have lost not as creamy, or it may be transition into a more liquid state. Okay, which is not unusual when you have butters, especially those that are not emulsified. So that's an example that's not particularly unique. Okay, then the state, so it was solid as a cream, and you may say yes, there is the result is now more, it's a liquid, and it is not stable, and the pH may still remain the same. Yes. Then you're gonna put it through the same cycle again. So freeze, thaw, heat, thaw, that completes one cycle. You may have some change now to the color, hypothetically speaking. Instead of it being a light brown, it is now a dark brown. The smell may remain the same. And from the control, to know, is there a change? So it may be, yes, it's the same slight change, no longer creamy, but it is more liquid state, and you can continue, you're finding the same results. Now what this allows you to do is to monitor the again, how the product is changing over time under these extreme conditions. Now, in terms of decision making, in some cases, you may have there's some changes which may be acceptable depending on the product. So you may have, for example, slight changes in color. If you're using natural ingredients, that may not be unusual. You may have some slight changes in color. If you also, depending on the product and how it is packaged, you may even have slight changes in fragrance, for example, over time. If you're not, for example, fully sealing it, you may have that difference. If there might be some separation in the emulsion or in the product, that might not be an unusual thing either. But there are some things that you may decide, okay, this is a no-go, right? So if you're doing microbial studies and you have 10,000 colony-forming units as a metric and you're finding 30,000, right? That's a no-no. If you have absent for S. aureus as a metric and you're finding that it is now present, then that's a no-go. If your pH is significantly changing depending on the product, that may also be a no-go, and it may require that you go back through reformulation exercises. So this is extremely important data to collect. In some jurisdictions, it is a requirement to actually provide a statement on stability. So this data, once you have it, you can save it as the raw data itself. You can save that as an appendix to a general statement to say these quality parameters were tested and these metrics were stable, these were not, and what the implications are for the customer, for its safety, for its quality. Method, which I forgot to mention, this is effectively, what is a specific way that you're carrying out that particular product testing. So color, for example, you may be doing visual inspection, or you may be doing some color photometry as an option. If you're looking at the size of your exfoliants over time, you may be doing microscopy. For your pH, you may be using a pH meter. But typically speaking, you should have SOPs for each type of test. Things like visual inspection, a smell test may not necessarily require an SOP, but if you do have an SOP, you can include the code for your SOP in method. Or you can briefly just describe what it is that you do. Smell test for, open caps and quick smell test. But typically speaking, you should have an SOP. That's just best practice, and you can reference that. In some cases, there are standard analytical methods. If you're using those standard analytical methods, so for example, if you are sending your product out for microbial testing, so a third party is testing it, or if you're using those standard microbiological techniques in your own facility, then you can list what that method is for reference. Okay, so it's actually very insightful to do this kind of exercise, but more importantly, it is very important to ensure that your products continue to function as it should, and also to maintain the form as it should. This ensures that you are compliant, and it also ensures that your customers continue to have confidence in your skincare, hair care, and personal care products. If you have any questions, please feel free to send me an email at hello@skincarestartup.com.